Hello and welcome to the course Introduction to the Psychology of Language. I am Arik Verma from IIT Kanpur and we are in week 7 of the course. We are talking about neural basis of different aspects of language. In the last two lectures I have talked to you about neural basis of understanding word meaning, concepts, and also in the last lecture I talked to you about neural basis of understanding word form or negotiating word form, spoken or written. In today's lecture, we will move to a slightly different aspect, which is basically talking a little bit about syntax and some of the other kinds of information. So, one of the things that is being said earlier as well is that it is not necessarily enough, it is not sufficient sometimes to just have negotiated the word's form completely and understood the word's meaning in some sense, because word meaning is not complete without also understanding the broader context in which the word has been uttered. So, this kind of brings us to the question of whether and when context starts affecting how you are understanding the meaning of a particular word. So, we have talked about in that sense. So, the question is that when is it that the context starts to come in and interfere or influence the way we are understanding a particular word. Okay. And this question is very natural to ask, because we never really are reading words in isolation. So, language is not lists of words. Language is words organized in phrases and clauses and sentences, organized in conversation and larger discourses, stories, so many things. Okay. So, because we are not really dealing with words in isolation, it's probably premature to say that if you've understood a particular word by its form and kind of gotten its meaning, you have completed language comprehension. There are other factors to it as well. Other information also needs to be taken into account. So, let us look at that. To understand the words in context, what we really need to do is we need to integrate the semantic and the syntactic properties of the recognized word into the larger representation of the entire utterance. What was I saying? Okay. So, some questions can actually have been, and some questions have been put up and can be asked about this particular scenario, and those questions are like, for example, at what point during language comprehension does linguistic and non-linguistic context influence word processing? What would be an example of non-linguistic concept? Suppose I have to say a particular word, I can say that very happily versus I can say that in a very sad way. Okay. In that sense, so that is also part of the context, that is also part of how you will understand the meaning of the word. We can say some very interesting compliments in a very sarcastic way. So, in order to understand that, you have to understand the sarcasm, which is a non-linguistic property. Okay. So, that part. Also, a question can be that is it possible to retrieve word meanings before the words are even heard or seen, say for example, when the words are highly predictable by the context. Suppose there is a conversation going on, okay, and you know exactly what this person wants to say or is going to say. So, you kind of already make a judgment of that this is what he will say now, and even before the person has uttered the word or moved his mouth in order to utter that word. You have not heard the word, but you've already predicted what is going to come in. So, how is it that context almost helps you exactly know what is going to happen? Okay. Also, say for example, a third question, and also a very important question, is that does context influence word processing before or after lexical access and lexical selection complete? Is contextual information taken into account during the lexical access process or during the lexical selection process, or once everything is done you have come up with a meaning and then you are trying to integrate with a context? What is really going on here with respect to how is context being used? Now, we have had some discussion about context earlier. We have talked about ambiguous words, biased ambiguous words, balanced ambiguous words. We have talked about neutral context and biasing context. So, just keep that discussion in mind when we are moving further here. Now, these questions, so that is what I was trying to say. So, this should also sort of remind you that word representation. So, one of the things that I will just add to that discussion is that word representations, an idea of what a word means, can be built up from two sources. One is the input level source, one is the lower level representations, basically based on the form of the word and how you are going to get to the meaning of the word. Okay. The other level is basically the higher level representation, broadly in terms of context, what is going to be said here, or say for example, I was giving you that example, my friend planted a tree by the bank, financial institution or river. Okay, so my friend planted a tree by the bank. Now, if you know me, if you know which friend I am talking about, or if you know, say for example, which city we are living in, if there are no rivers here versus if there are no banks here, if we are living in a village, all of this will kind of in some sense dictate how you understand the meaning of the word bank at the end of this utterance. Or in order to really understand what bank meant, you have to take into account all of this context, all of the whole of this utterance, the knowledge about myself, my friend, the city we are living in, all of that. So this is the idea. So there will be, this will be the higher level representation, BANK, and combining that and coming up to the lexical access part is the lower level representation. Either form of representation is obviously incomplete without the other one, and the interaction between two is therefore very natural and is very imminent. That will happen at some point of time. Information from both kinds of representation should converge and help us to correctly understand a particular word. Okay. So the actual point at what point this convergence or this interaction really happens is the one that is debated. There are three kinds of models which talk about how this interaction might be happening. There are modular models, there are interactive models, and there is a hybrid model. The modular models basically, borrowing from the modularity theory of Jerry Fodor, basically proposes that language comprehension is basically achieved, with the help of separate independent modules, and these modules do not interact with each other. So perception, comprehension, context is something else. So language comprehension does not. So language comprehension is achieved within the language module, and everything that is non-linguistic outside this particular module will not be taken into account. So they reject the possibility of an interaction between context based and input based representations. But we have talked about a fair number of studies where we see that this thing is taken into account. If you remember, that particular sentence, rumor had it that the government building had been plagued with problems. Many, the people found many roaches, insects, and bugs, other bugs in this building. And when people were presented with words like ant and spy and sky, they really kind of, they took into account this information. So we know that this probably is not true. The other kind of model that you can talk about is the interactive model, and the interactive model basically proposes that all types of information, context based and input driven, interacts in order to achieve the word comprehension. This is typically the trace model and those kind of things. So McClellan and colleagues had proposed such a model that allows for feedback between top levels, from the word levels to the letter levels at least, and that interaction kind of is taking into account that thing. And then you have the third kind of models, the hybrid models. The hybrid models typically tend to constrain information about word forms, so that are possible by the given context, and they rule out such candidates that are improbable given the context. So hybrid models basically already narrow down on the possible candidates that will be activated. So they already said, okay, we are talking about cricket, we are on the cricket ground, we are all, say for example, in the kit. And then whenever the word bat is uttered, you know exactly what is it that we are talking about. So these are the three kinds of models that have been there. Now in a very interesting experiment, Zwirtzelud and colleagues basically showed that participants were actually faster to respond to meanings that were licensed by context as opposed to meanings that were not licensed by context. So it kind of tells that, okay, in word meaning, role of context is there, context is being considered. So the process of lexical selection, therefore, to be more specific, is actually influenced by the contextual information available from the conversation or the text within which this particular word was embedded. The proposal that lexical selection is influenced by high level contextual information has also been supported by some of the other studies. For example, Maslin, Wilson and colleagues in 2011 performed fMRI studies of the word recognition, and they demonstrated the fact that the process of lexical access and selection actually involves a network that includes the middle temporal gyrus, superior temporal gyrus, and the ventral inferior and bilateral dorsal inferior frontal gyri. So, these are the areas that were activated. They found that the middle temporal gyrus and the superior temporal gyrus were actually important for the translation of speech sounds to word meanings, and the frontal cortex regions were also found important for this selection process. Now, you could remember the binders model, you can kind of go to the last lecture and see what areas I am talking about. Further, they found that greater involvement of the dorsal inferior frontal gyrus basically occurred when selection required choosing the actual word from among many lexical candidates. So, these could be the regions wherein context based information is kind of being factored in with respect to, say, for example, selecting the exact word that is in question. This was broadly about context and words. Let us look at a slightly more narrowed form, which has to basically do with integrating particular words in the sentence. Where is the word uttered? It is uttered in a sentence. How you integrate the word with the sentence. So, as we have discussed earlier, understanding language requires us not only to understand individual words, but also to be integrate the meanings of the words into the sentence. We have talked about this. We talked about this example of bank being a financial institution on the side of the river. We have talked about the example as well. Let us move further. Now, higher order semantic processing is basically important to decide the right sense or the meaning of the word is is in the context is there. Syntactic analysis, however, is also a very important step. So, not only at the level of semantics, but whether the word is syntactically fitting there or not. Is it syntactically structurally expected there or not? Okay, this is also a very important step, and because syntax kind of gives you an idea of the underlying structure, it kind of gives you an idea about whether it is an actor or a object or subject of the sentence and so on. So, that part is there. Now, while the brain actually does store the words semantic and syntactic properties, let us say in the mental lexicon, it has to assign the sentences a syntactic structure on the fly. How many sentences that we speak and hear every day. It is very difficult to store structures specific to sentences. That is not what the brain does. It probably stores information relevant to the words. We probably hardly know around 50,000 to 60,000, 70,000 words. So, that maybe is easier to keep. But with sentences, we know so many sentences, and the sentences even with the same words can be said in so many different ways. So, what the brain needs to do is it needs to compute those structures on the fly, on the go. Okay. We talked about the constraint based parsing models, we talked about Lynn Frazier's garden path theory, we talked about good enough parsing, race based parsing, construal based parsing, we talked about so many of these things. Alright. So, all of this is kind of somewhere being accomplished in the brain. ERPs and fMRIs have been used. So, ERP is the event related potential, fMRI is functional magnetic resonance imaging. We know that these techniques have been used to look in the brain while it is performing the task and while it is unraveling both the syntactic and semantic aspects of sentences. So, let us look at this a little bit more closely. From ERP studies, two particular components have come up which are very important in understanding how the brain is analyzing the structure. The first of those components is the N400 component. If you read this sentence, after pulling the fragrant loaf from the oven, he cut a slice and spread the warm bread with socks. As soon as you read the word socks, there is a negative potential forming in the brain at around 400 milliseconds, which is the N400. It was first reported by Kutas and Hilliard in 1980, who were the first to report this N400. N400 typically is a negative polarity. It is a voltage peak in the brain waves, usually reaches peak amplitude about around 400 milliseconds after the occurrence of the anomalous word. What is the anomalous word here? The word socks. N400 has been reported to be sensitive to the semantic aspects of the linguistic. When the meaning anomaly is there, then N400 figures up. It has been shown in various studies that N400 is specific to semantic anomalies, and it does not get evoked if syntactic or physical deviations are there, or musical or grammatical deviations. It is only there in case of semantic anomalies. Also, the N400 response has been shown sensitive to comprehension of language that even goes beyond single sentences, in broad structure, whether the particular word is fitting in the broad structure. So, this is in a sense of how this higher level representation is stabilizing or is not stabilizing in that sense. This is an example figure from Gazzaniga. You can see here this is the N400. Okay, this is where the N400 is there. This negative peak at around 400 millisecond. Okay, so he spread the warm bread with socks. That is where you are seeing that. It was his first day at work. He spread the warm bread at socks. As soon as socks happens, she put on her high heeled shoes. So there you see there is no thing. You can see these sentences. So there are no N400 for the first and the third sentence, but there is a N400 at around the time they hear socks with the dotted line. Another ERP component that has been observed is P600. Osterhout and Holcomb and later Hagood, Brown and colleagues, they actually reported a positive ERP component around about 600 milliseconds after the onset of a critical word that were incongruous with the expected syntactic structure. So N400 was coming at semantic anomalies. P600 usually comes up with syntactic anomalies. If a word is placed there which is not licensed by the syntax of that particular language. So for example, enraged cow injures a farmer with an axe. Okay, it is a temporarily ambiguous sentence, or drunk gets 9 months in violent case. These kind of places, these words are grammatically inconsistent, because you do not exactly know what to make out of this. Is the cow using with an axe as an instrument, or the farmer is having with an axe? You remember all the parsing lectures. With an axe is a prepositional phrase. It could either get attached to farmer or it could get attached to enraged cow. If you attach it to enraged cow, it leads to a problem. You will need to attach it to the second one, to the injured, to the farmer. So this is why you can expect a P600 coming up right about here. In a study that Hagood, Brown and colleagues did, they asked their participants to read the sentences presented one at a time on the screen, and they measured the brain responses to normal sentences versus to sentences like the ones which we just read. They observed a large positive shift, especially which was responsive to the syntactic violation in the sentence, and the onset of this shift was observed to be around 600 milliseconds after the violating word. Okay, so with an axe around there, you can observe this shift. The P600 basically shows up in responses to other kinds of syntactic violations as well, and it occurs regardless of whether participants are listening or reading, so independent of modality. This is where you can see there are two examples. So one is in Dutch and the other is a translation. So het verwende kind Guyen or Guit het speelgoed op de grond. So this is Dutch. Basically here the word that is being used is Guit, but Guyen should be used. So going, throws or throw. So the spoiled child throws the toys on the floor versus the spoiled child throw the toys on the. So something that is not syntactically licensed will lead up to the P600. Immediately after 600 milliseconds of that, you see the P600 coming up. So this is happening, these words are coming at around 1200 milliseconds. You see that the P600 is kind of coming at around 1800, a little bit further than the 1800 milliseconds mark. So this is P600. Now the syntactic processing or syntactic violations have also been reported to lead up to other kinds of components as well. Say for example, Munte and colleagues and Friedrichi and colleagues in 1993 described a negative wave over the left frontal areas of the brain, and they termed this as a left anterior negativity. Anterior because frontal and it is a negative peak, which has been reported when words violate the required category. So a noun is expected, a verb comes in, that is where you can expect the LAN to come up. Okay. So the LAN has almost a similar latency as the N400, but it has a different voltage distribution over the scalp. So this is also one of the things that has been observed. Here you can see, say for example, the distribution of the N400 versus the distribution of the left anterior negativity. You can see the time is frame is around similar. So, N400 is happening within N400 to 450 milliseconds, LAN is happening between 400 to 450 to 500 milliseconds, but you see that the geographical location, the spatial location in the brain is slightly very different. So, the distribution of LAN is more in the frontal areas, whereas the distribution of N400 is more in the temporal areas. This is the top view of the brain. So, this is the temporal area basically where this is there, and the temporal area more towards the left side. Here you can see it is happening in the anterior area of the brain. Okay. So, that is why even though they are similar effects, they are kind of indexing to different kinds of qualitatively different kinds of effects. About the areas of the brain involved in syntactic processing. So, some other kinds of research has also happened which kind of talks about the spatially spatially which areas of the brain are there. So, what has been shown is some patients with brain damage show severe difficulty in producing sentences and also understanding complex sentences. Patients suffering from agrammatical aphasia generally produce 2 to 3 word sentences consisting sometimes exclusively of content words, nouns, verbs, adjectives, no prepositions, articles and so on. And they also have quite a lot of difficulty understanding complex syntactic structures. Problems in understanding syntactic structure has actually been linked to lesions that happen in the Broca's area in the left hemisphere. Also, it has been shown that the left inferior frontal cortex around the Broca's area has more involvement in syntactic processing. So, when syntactic processing is at fault both in production and comprehension, the Broca's area is usually implicated. So, if I were to draw this for you, this is where the Broca's area would lie. This is where the Broca's area would lie broadly, I mean. Why? Because this is anterior, this is in the frontal lobe, and this is inferior, and it is in the bottom, and it is basically, yeah. So, the left usually happens in the left. So, left inferior frontal lobe, that is the Broca's area. Further, in a set of PET studies, Kaplan and colleagues have found out increased activation in the left inferior frontal cortex for processing complex syntactic structure. So, this is the area which is also tagged if you are reading a more complicated syntactic structure, those globally ambiguous garden path sentences. Okay. While Susan was dressing, the baby played on the floor, those kinds of things. In addition, portions of the anterior superior temporal gyrus, so superior temporal gyrus, we have seen that in the figures earlier, and the anterior part of it has also been implicated as a candidate area in complex syntactic processing. So, this area is also kind of being involved. This is basically all about the syntactical processing and the areas of the brain that might be involved in syntactic processing. I will talk to you about something else, some other neural bases in the next lecture. Thank you.